Namaskar दोस्तों, welcome to channel Toxicology on board. Today in this video we'll be discussing another DABT topic, that is the strength of evidence and weight of evidence. So let's directly dive into the question. So this question is taken from ABT recertification question paper year 2000. So the concept will be with respect to risk characterization. So let's see what is the question. Which of the following is or correct concerning the concepts of strength of evidence and weight of evidence? So we need to identify which of the following statements are applicable to strength of evidence and weight of evidence. So we'll see what is option 1. Option 1 is the strength of evidence refers to the degree of conviction regarding the outcome of an experiment. That means there is a clear evidence of a carcinogenic activity. So such statement uh, will be applicable to strength of evidence. Second statement is strength of evidence refers to carcinogenicity potency or to mechanism of the action of the chemical. So this whatever the strength of evidence, no, it is not related to potency here. So this is and it is not clearly defining the definition of this strength of evidence. We'll see. Now we are just going through the options. We'll see what is the actual comparison and difference between both the strength of evidence and weight of evidence in the subsequent slides. Let's first go through the options. Option 3 is weight of evidence involves consideration and integration of all relevant human and long-term animal studies. This particular third statement is, it is the apt definition, correct definition for the weight of evidence. Fourth option is weight of evidence refers to the amount and the kind of data from a single experiment. So this is not a weight of evidence is not from a single experiment. It is from the multiple experiments. As you can see in the previous statement also, it consists of all human data as well as long-term animal studies. So it can't be from a single experiment. So fourth statement is not applicable. It is not correctly defining the weight of evidence. Okay, so the right answer will be in the green text, that is option 1 and 3 are correct. Strength of evidence refers to degree of conviction regarding the outcome of a particular experiment. Weight of evidence involves consideration and integration of all human data as well as long-term animal studies. So let's see what is the definition of this particular strength of evidence and weight of evidence. So we'll try to read the concepts which are related to these two topics. Okay, so the process of assessing all available data in order to reach a consensus about what the body of the data is in effect communicating to the evaluator is known as weight of evidence. So in the case of weight of evidence, in a simple layman language, is that you have multiple experiments. In vitro data is there, in silico data is there, preclinical study data is there, human data is there, cohort studies, epidemiological studies. So when you gather all this in data, then you come to a common conclusion. Some of the results might be conflicting, some of the results may be positive, some of the results might be negative. So you have to take into consideration all the results from various studies. Then you have to come to a common conclusion. So that is called weight of evidence. The goal of a weight of evidence approach is to produce a consensus statement about what is known about a given chemical so that available information may be used. So now you are gathered the information, you got the results. Now how we are going to use this particular information? So this particular final conclusion will be used by the risk managers, may be used by the risk manager, policy makers and other stakeholders to determine how to respond to a certain risk and whether to consider that particular chemical as a chemical of concern or not. Okay, so for example, there is certain chemical which is spilled in a certain area, there is a ship wreckage, or say there is some outburst or some accident, industrial leakage is there, certain chemical X is there. So we need to have the information on that particular chemical X, and we have to see overall. Once you have all the information, no, this risk managers or or the policy makers will sit together and they will decide, and they will make they will categorize under what particular concern this particular chemical will fall into, and how the next risk mitigation measures need to be done. Okay, so for this purpose you need to have weight of evidence approach. This is particularly done by the risk assessment toxicologist. This, and it will comes under part of risk characterization. So there will be different steps. This is the taken. This particular information is taken from the book Toxicology Risk Assessment. These are the authors. So this book is, if you look into DABT brochure 2026, you have list of references is there, list of textbooks are there. So first the textbook that you will come across is Clayson textbook. Then you will have Hayes Principles of Toxicology. Then one book with respective risk assessment will be there, and that book is Toxicology Risk Assessment Beginners. So we are discussing this topic, strength of evidence and weight of evidence. This particular information is taken from this particular textbook. So you have to understand, if you look into the ABT syllabus, no, we have a 30%, 35 marks will be on the risk assessment only. So it is always good in addition to Clayson, because in the Clayson fourth chapter they have detailedly discussed dedicated to risk assessment. Okay, but in addition to that, but it is always, in addition to Clayson textbook, it is always better to at least read one book on risk assessment. Either you prefer this particular toxicology risk assessment for beginners, there are other books also from different authors are available. So at least one book you have, so you read or you have on your bookshelf, so that you will have a complete picture about this risk assessment. So let's go back. So these are the various steps. This particular flow diagram is taken from this textbook only. So first step is collection and evaluation of the all available data, which includes in silico, in vitro, animal studies, human studies, epidemiological studies, case control, cohort studies, everything. Then hypothesis, synthesis of evidence. It consists of both positive, negative, conflicting, equivocal, like that, and evaluate plausibility. See, these terminologies, no, plausibility, temporality, all these things you will come across. It is there in the syllabus also. Barred fold yield criteria will be there. In that they have listed around 9 principles, 9 criteria they have given. So there again we will see what is the definition of plausibility also. So we need to evaluate the plausibility, which includes data quality. Data quality means whether the study is done in GLP or non-GLP, whether the study is published in a scope, if it is there, if it is an article, if it is published in a Scopus journal or a free published journal, like that. The authenticity of that particular publication data quality you need to check. Okay, then uncertainties will be there with respect to data. Consistency, is there any if the same experiment is repeated, are we getting the same results? Inconsistency, mode of action also you have to see. Then is there any relationship of these results with the humans data? Then rationality, reasonability, and identifying if there are any data gaps. For example, if you look into a battery of toxicology studies, if there is repeat dose toxicology study is there, but there is no reproductive toxicology study, so that is the data gap. Okay, of course you can use some uncertainty factors and extrapolate the repeat dose noel to reproductive noel, but yet you need to identify those data gaps. How you can fill? By using predictive prediction, or by using uncertainty factors, how you can fill the data gap, that also comes under part of evaluating the plausibility. And once you get, you have to interpret of this evidence of causation. So you need to develop a relationship between the cause and effect. So is it possible, plausible, or it is not plausible? Then what is that? Then you have to go to back to the same step, that is you have to frame an alternative hypothesis. At first, when we go through this chart, it might appear little bit challenging, but if you look into all the NTP studies or IARC studies or EFSA studies, EPA studies, they will follow this type of a decision tree only. And particularly those people who are toxicologists who are working on ECA-REACH dossier also, you will come across this Bard-Folded criteria. Okay, so we'll see another slide to understand in detail more about weight of evidence. This weight of evidence approach is advantageous because this weight of evidence, no, it provides an objective means of dealing with a diverse body of scientific data, which is particularly important when stakeholders involved in the process lack unity, because there are different decision makers will be sitting in that particular panel. Some of them will vote for yes, some of them will vote for no. Okay, so there is a lack of unity is there regarding the interpretation and application of available data. If I tell you in a simple language, you have a certain chemical, you have literature from the FDA, from the EMA, from the TGA, that is Australian, or from the Japan, that is PMDA, and you have from Canada. for the same study, once for the same chemical, for the same study, FDA is saying some, for example, it is saying NOEL as 100, EMA is saying NOEL as 50, and some other is saying 100, some other is saying NOEL cannot be derived, it is LOAEL. This kind of challenge you will come across when you do the literature search. So at that time, what the decision need to be taken is, you need to consider the primary source of reference. Means you have to identify out of all this publication which was the earlier publication which is containing the detailed studies, and because rest of the people are copying the data from the primary source. So you have to reach the primary source instead of looking into a bit of a part of the literature. You need to look into full-fledged study. Okay, so there will be uh, disagreements will be within the panel only, between different toxicologists, between different researchers or scientists. So there will be lack of unity regarding the interpretation and application of available data. There, for example, there is some adverse effects. I am a toxicologist one. I assume, I think that this particular decrease in body weight or decrease in heart rate, I'll consider this as an adverse effect. But there will be another toxicologist too, who will say based on his experience or comparing it with the historical data, he might he might have a better explanation stating that this particular thing is not an adverse effect. So there will be disagreements between the toxicologist only. So regarding the interpretation and and application of this available data. Okay, see, you have to read this risk characterization or risk assessment with examples only, then only you will be able to understand, because this is not an experiment. Experiment is done, the literature is there, data is there, interpretation of the data integration is needed. So how to understand these principles is, you have to always think about examples, then only you will be able to remember these concepts. Then scientific data regarding chemicals of concern may come from diverse array of sources. As I told you, it can be in silico, in vitro, then animal studies, small animal studies to rat, mice, rabbit, dog, monkey, like, and up to human or epidemiological cohort studies will be there. Epidemiological studies, laboratory studies in animals, tissue culture models form the basis for a hazard identification of a data-rich chemical. If there is, for example, data-rich chemical like any alcohol, isopropyl alcohol, or diethyl methane, or dimethyl formamide, or tetrahydrofuran, or there are some examples of benzene for which plenty of literature is available. Huge amount of epidemiological case studies or case control studies are available. Okay, so there is a data rich chemical. So when you have diverse information, it becomes much more challenging to integrate and come to a common conclusion. However, other sources which may provide less detailed information may be of use in cases where little is known about a chemical of concern. So there are two types of things. For example, there is certain chemical, either you have data rich chemical, like you have full battery of toxicology or in vitro in silico studies you might be having. Certain times there are certain chemicals which were only identified when you perform a HPLC, like you will have in the peaks, but you will not have even CAS number to identify to perform the literature search. So these are completely scarce. There will be no literature or no NOEL or LD50 available for that type of chemical. That also becomes a very challenging for the toxicologist, how to risk assess or risk mitigate such type of chemical. Then he has to purely depend on in silico tools, either QSAR or Derek or Lhasa, like that. Okay, so so these are the list of different literature source engines which were provided in that particular textbook only. So PubMed is the thing where you will easily get the articles which are the latest articles that are there. You can use the filters and get the publications. There will be certain databases which are dedicatedly only for toxicology, databases will be there, which are paid databases will be there. During my first job, I used to work on Tox Planet. Uh, then we have other things you can get it in PubChem only. So we have one you will come across when you perform literature search, that is OECD, screening information data set. SIDS document you will be getting. In that you will be getting NOEL, LOEL, and LD50, and you have NLM, but ToxNet is no longer available. But all the data has been, some of the search engines have been pooled in the PubChem. Then you have US EPA Actor. Then you have integrated US EPA IRIS, which gives you RFD and RFC. Then you have ATSDR, in which around 500 to 600 chemicals are being listed, where you have minimum risk level. So you have all the NOELs and LOELs for the listed chemicals will be there, and they have done some risk assessment and they have derived MRL, that is minimum risk level. Okay. Then you have provisional peer reviewed toxicity values. PPRTVs are one which will give you provisional RFD and provisional RFC. Later on, these, when you have ample data, then these will go to RFD, that is reference chronic reference dose and chronic reference concentration you will be having. Then you will come across IPCS also in chem, where you will have WHO related acceptable daily intake you will be having. Then NICNES is also very good document related to Australia, I believe. So there also you will get different point of departures, NOELs and LOELs. And similarly, RETEX document is there, where you can get LD50, TDLO and LCLO. So these are the various risk and NTP studies are also there. So these are the various search engines where you can get the toxicology information. By using this information, see, first step in the risk assessment is hazard identification. Second is getting in the part of hazard identification only, you need to gather all the toxicology studies, all the point of departures, NOEL, LOEL, LD50, whether it is TDLO, LCLO, or you have TD50 or from the CPDB data also, base also. So gathering the information. See, in a simple analogy, I will say, if there is a case is there, and if a lawyer is if an advocate is solving that particular puzzle or that particular case, he need to have all the evidences on his table. Then only he can able to solve that particular riddle or that particular puzzle. So similarly, toxicologist also, he need to have all the information on that particular chemical X. Then only he can be able to take the decision. But if you are in the halfway, like in the second step or third step, then a new information comes, then it will be very challenging. See, another thing also you have to remember, science is dynamic. You will definitely get new information, but at that point of time when he is doing risk assessment, at that time all the information and that particular year or particular time, it should be available. Eventually, next year or next month, you will have new data. Again, the risk assessment need to be again it has to be risk assessed that particular case. New information, new limits will be again uh, based on new information, again re-evaluation will be done. But at that particular time, all the information should be there, then only based on that information you can take the decision. So next we'll see, in addition, we are still discussing the textbook only. So in addition to there being data, that must be synthesized from diverse sources, weight of evidence approach must find a means of prioritizing or weighing the data to select which data are to be given the greatest significance. As I told you, you have to give importance to the GLP study instead of non-GLP study. If you have a acute study and chronic, if you have 28-day study and 90-day study, you have to choose the 90-day study. Like that, every step you have selection criteria will be there. The outcome is more consistent, scientifically defensible, because whatever the limits which you are doing, which you are deriving, you have to be able to defend it in the presence of regulatory body, and transparent approach to data evaluation. There should not be any bias. When data from diverse source supports the same conclusion, if you're getting information from one FDA, EMA, TGA, and all of them are giving the same conclusion, this alone leads to a greater confidence on that particular conclusion on behalf of the evaluator, that the outcome of the evaluation itself is scientifically sound. Luxury is not available for the chemicals with limited information of data. So there are certain chemicals for which there is less data scarce is there, then it becomes much more challenging. However, the goal of weighing data is to use the highest quality, most reliable data upon which to build a risk assessment that is fit for purpose, identified in the problem formulation and scoping phases. So see, what we are discussing in this video is strength of evidence, weight of evidence. More focus is towards weight of evidence. In weight of evidence, we are discussing that particular risk assessment textbook. Why we are discussing is, it is a part of ABT brochure only. If you look into risk characterization management, we have here this particular point: perform weight of evidence analysis to reach conclusion and inform decision making. So eventually in the risk assessment, it comes in the part of risk characterization and risk management. This is useful for the policy makers. Weight of evidence criteria for integrating potentially disparate lines of evidence. So in that they have given the example Bradford Hill criteria. About this criteria, 9 points are there. I will mention them towards the end of the presentation. So this is the typical flow diagram which is taken from that particular textbook only. Problem formulation and scoping. Assemble available data. Now we understood because we have seen the search engines also. Body of the data, that is weight of evidence. Hazard identification. Then analysis. Particular stakeholder and input he will take. He will make the decision making. He will do the risk characterization, risk management options, decision policy making. So these are all part of this particular risk assessment process. So pause here. It's difficult to explain. Once you start working on this area only, you will be able to understand. Those who are working already in risk assessment, they can connect with me. Okay. So we'll quickly do a comparison between these two, weight of evidence and strength of evidence, because the question was with respect to strength of evidence and weight of evidence definition. So in the toxicology, weight of evidence is a systematic approach that integrates all available heterogeneous data, okay, including studies with conflicting results, mechanistic information, exposure relevance, to reach a scientifically defensible conclusion on hazards. To whom you are defending? You are defending it to the regulatory body, either to the FDA, EFSA, EMA, like that. Strength of evidence refers to quality, consistency, and reliability of a specific evidence. My understanding is strength of evidence means there will be one article will be there. So what is that article? So focus is towards only one particular article or one particular study. Okay, what is the quality of the study? What is the quality, in which journal it has been publication? Is there any consistency in the results? So it is related to one particular study or one particular article. Whereas coming to weight of evidence, it includes all, from in vitro, in silico, preclinical studies as well as epidemiological human studies. So while weight of evidence evaluate totality of the evidence to determine the overall risk. Layman language, advocate is there. If he is only asking one person about that particular accident or incident, that comes under strength of evidence. If that particular advocate is asking two, three witnesses about that particular case, murder, or that particular incident, then that comes under weight of evidence. Okay. So let's see, because one particular person might have some bias, but the same results you are getting from different persons, then that will add more strength to that particular conclusion. Okay. So let's see very quickly the comparison. Weight of evidence is comprehensive process of assembling, weighing, and evaluating all information, positive, negative, and mechanistic, including mechanism of that toxicity is also involved, to reach a conclusion. Weight of evidence is used to overcome limitations of relying on a single study. We are not depending on a single study. Single study, certain times there might be some bias will be there, especially when the data is complex. Coming to strength of evidence, this refers to the confidence in a particular study or set of data, generally ranked by quality. High quality data, moderate quality data, or low or insufficient. Okay. It examines factors like statistical significance, methodological quality, and dose response relationship. Because you have to see whether the study has been done as per OECD guideline, whether the study has been done with GLP. So those things are also add to that the results, to strength to that the results from that particular study. So quality and reliability, well-designed studies, example GLP studies are given higher weight when compared to non-GLP. Relevance, data on high human health is generally weighed higher than animal data. So when you have human data, animal data, if the final consumer is human, you have to give reference to human data, which in turn is weighted higher than in vitro cell studies. So there will be you yourself can make a that like in silico, in vitro, then it will be in vivo, then human, like that. Consistency, similar results across different studies. So you have to get say if you're following certain guidelines, you have to get the same results. Species or laboratories strengthen the evidence. Qualitative, expert judgment is used to categorize evidence into level of concern. Quantitative, scores are assigned to data based on predefined criteria to calculate an overall score. There will be some scoring will be there. ECA, if you see in that for a particular article, no, if you're for that particular study, they will give you some scoring 1, 2, 3, 4, like that. When they consider read across also, they will be giving some scoring will be there. Often Kilmich score, that is called Kilmich score, often used in mode of action analysis. Regulatory application, organizations such as EP and EFSA use weight of evidence to classify substances whether the certain chemical is carcinogenic or not based on all available data rather than just one study. That's why we are doing my study, rat study also. We are comparing. You have one expert EAC committee will be also there. So you have one same slides will be also be read by peer reviewers of that particular slides will also be there. So peer reviewer also should also give the same type of, the results should be in alignment with the study director or study pathologist. So like that, these points are also very very important. So since we have already seen in the ABT brochure under risk characterization that particular point at all, under weight of evidence Bradford criteria will come. So in the textbook only, this textbook is also referred by the ABT brochure only. So they have given in that Bradford Hill criteria, they have given what is how to define that that evidence, which includes strength, consistency, specificity, okay, and temporality, biological gradient, that is dose response relationship, plausibility. We have seen in the decision tree plausibility, then coherence and experimental evidence and analogy. So these are around 9 points are there. So we'll discuss about this Bradford criteria in some other video. Okay. So for the time being, you can pause here, and if you are interested, you can read the comparison. What this Bradford Hill criteria is saying with respect to this criteria, and what are the limitations which are given by another scientist, that is Rothman. So are they in alignment or is opposing, that you can stop and you can read. Okay. So thank you so much. Be curious. For any questions, you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.